entrepreneur, sold his company to Microsoft in what Microsoft calls one of its most successful acquisitions. After that, he went on to become a partner at Mayfield, where he co-leads a practice that's called engineering biology. Mayfield is one of Silicon Valley's oldest venture firms and among the most reputed VC firms in the world. Ursheet is also a founder and trustee at Plaksha. Professor B.L. Ramakrishna started off with studying chemistry in undergrad and masters, followed by a PhD in material science from IIT Madras. He had an illustrious career as a professor in Arizona State University for over 30 years, after which he took a very exciting role at the National Academy of Engineering in Washington, D.C. For those of you who haven't heard of NAE, it's really the nucleus of where discussions around the future of engineering, education, and research happen. And a key aspect of that is how engineering needs to be linked to grand challenges. And Rama joined NAE as the founding director of their Grand Challenge Scholars Program. He now plays the role of the chief academic advisor at Plaksha in a full-time capacity. Both of them are joining in from the US, from San Francisco and Arizona, respectively. Ursheet, Rama, thank you so much for joining us today, particularly given this is a late Friday evening for you. Without further ado, I'll jump straight into the session. For the first half, I will ask some questions to Ursheet and Rama from our side, after which we'll open it up to Q&A from the audience. In the meantime, if you have any questions, please feel free to put them anytime in the Q&A box. Okay, Rama, to start with, biological systems engineering is a new term for many people who are attending today. So could you briefly explain why there is such a buzz around biological engineering now? And could you unpack the meaning of this term for the audience?
Yeah, thank you, Palvi, and for that introduction. Really nice to meet you all virtually. Whenever I address people like you just beginning their academic and professional careers, I wish I was a student like you now, because it's one of the most exciting times ever to be learning engineering and applying it to address all these problems. I just want to capture why it is the case. This slide shows a little bit of the kind of history of technology, if you will, starting from kind of almost the industrial revolution and to where we are now. In the beginning, it was kind of physics. Heat was kind of the major role played in that revolution. The first, second, third, fourth industrial revolutions, they're somewhat aligned to these four that I put here. But as you keep going further down towards biology, which is what it is just in the turn of the last century and the beginning of this century, lots of exciting developments have taken place, beginning with the structure of the DNA, which was around 1950, to where we are now with genomics and proteomics. And now this is a time where we can both learn how to apply engineering to address biological problems, and also be inspired by biology to do engineering in a better way. So this is why I think this is one of the most exciting times. And just to kind of tell why this is different from biotechnology that you might have heard of, biotechnology programs have been around for a while. Those are mostly in the kind of agriculture and biochemical processing of making large enzymes in factories and so on. But that's not what we're talking about here. What we're talking about here is the kind of the convergence of engineering, modern biology, and computer science coming together to address these problems in wonderful ways. So you now have the tools to address these things in the most innovative ways possible. And that's why I feel, I wish I was starting to be a student right now.
Thanks a lot, Rama. So you spoke about this convergence of biology, engineering, and computing. And we heard about how this sort of intersection is really creating the largest impact in the world today. So Ursheet, if you could help us understand what are the sort of innovations and ventures that are being created at this intersection now? And if students come into Plaksha, then how can they contribute to these sort of ventures and making this impact in the world?
Sure. So there's several things in that question, and so I'll sort of answer it in terms of what is unique and different about the ability to engineer biology today and what that does for the world. And then there's already a question in the chat on how do you start pursuing a career to that effect, and then what kind of careers are we talking about, and what does the next 10, 20, 30 years look for in those careers. So if we look at 2020, the biggest thing that everybody will remember out of that year will be the COVID-19 pandemic. And if you wondered why is it that this time around we could get a vaccine within 1 year, where before this, anytime a vaccine had to be created, it takes 10 years. And the reason is because we are no longer sort of, uh, working in a world where we have to guess what is happening in biology. So what has happened is that you can digitize biology very easily. You can do gene sequencing, which has gone from $1 billion a person to like $100 a person. Not only do you sequence the average genome of a person, but you can now actually for $1 sequence individual cells of a person as well. You can create RNA, DNA molecules on demand with CRISPR. And then you can use cloud and artificial intelligence to understand this very granular level of information and use it to create new applications. So this whole category is like the computing industry in the 80s and 90s. And an example of what it does is it significantly accelerates the way in which we can understand and treat disease, understand and create new foods, plants, clean air, water, new medical devices, the works. Uh, so that is fundamentally the kind of things that we are seeing. What has also changed is that 20 years ago, if you had to start a company with biology, it would cost actually 10, $20 million to start something. Today, there are accelerators all over the world, including some of the more successful ones, which are deep collaborations with Plaksha, called IndieBio, that have created 150 companies that are worth over $3 billion within 5 years. And each of them started with $250,000, which I would say is like 2 crores, right? So it has actually become much easier to start this category of companies. In terms of the jobs for people who graduate out of this, so pretty much most of the biopharma industry that is there um, in US and China is going to start sort of creating opportunities in India. The classic chemical drug industry itself is going to move towards sort of biopharma, which is drugs that are made, or the biology based products like DNA, RNA, proteins, CRISPR, gene editing, cell engineering. That approach is not just in sort of healthcare, but that is also in things like agriculture, materials. You can now have companies that are able to take pollution from the air and actually convert that into products. These products could be things like bricks, or these products could actually even be things like fuels. So it's almost like a magical set of things that are possible. And so the jobs over here come in startups that are doing this, large companies that are entering these categories, right? When COVID-19 happened, one of the first things, conversations I had from was to talk to one of the heads of the Tata Group here, and they actually have now done a CRISPR-based vaccine in a record amount of time out of India as well. You also have job prospects with regards to um, US multinationals. Just as in IT, you have a lot of the multinationals that have basically India offices. You're beginning to see something similar happen in the biology space, bioengineering space as well. And then over time, this will actually become the better path for immigration or higher studies. There's just a much greater level of scholarship and research opportunities because it is the frontier area. And so you do see that sort of globally, that as kind of the opportunity. Um, I'm incredibly excited. I mean, I had a whole life and career in computer engineering, and I've committed myself out to this area. One of the things I also noticed is when I saw entrepreneurs of Indian origin in the US, the hurdles that they had to cross to sort of get to the US standard was very high. In fact, in IT, we would find a lot of entrepreneurs of Indian origin. The And it sort of came back to, but in bioengineering, almost all the entrepreneurs I work with, 90% of them are not from India, versus like in IT, it's more than 50% from India, and at a global level. And so when I'm looking at this, I'm seeing where the core challenge and issue is. And the understanding was that, we've not really created world-class bioengineering programs. And this is why we picked the top colleges um, in the US for these programs, and they have become deep collaborators in creating this program, right? Rama's as great as it gets, but besides Rama, his partner that is creating this program is one of the key directors out of Harvard. The chair of Stanford's bioengineering program is a key advisor. The dean of engineering of UC Berkeley is a key advisor. And we are one of the top VC firms around this domain, and I'm really hoping that that this program generates excitement, because I think our goal is, and we seem well on our way to creating one of the best degrees in the world for this class of, or for the best bioengineering degrees in the world. So very excited that, the broad community at Plaksha has come together to rise up to this challenge, and we are getting such incredible level of support from anybody we reach out to in the world. There's a great question here. Is it necessary to have biology to pursue such careers? The short answer is it's actually not. And so I'm a prime example. For a lot of, I don't know how it's in India right now, but I was actually a PCME, right? So for 12th standard, physics, chemistry, math, and I don't want to do medicine, so I'm going to go to electronics. And fundamentally, what is different today is I have a daughter who's now in 10th standard, and I see what she's studying. And everything she's studying in physics, chemistry, math is the same as what we studied, but biology is fundamentally different. The world has advanced so much. When we were students in school, this DNA, RNA, understanding the human genome was like cutting edge, and to see how that has translated into practice and how things have moved so fast on it is totally delightful and sort of fascinating. And so, this kind of a field requires understanding a little bit of biology, but a lot of chemistry, a lot of physics, material science, thermodynamics, mathematics, as I said, software engineering. Pretty much anybody who graduates with this degree will be pretty ready for any software job, right? That's a given. That's a skill that you need. But there's a bunch of this other stuff that you need on this cross-functional sort of, degree. Because anybody can write software, but not anybody can be a bioengineer. You do need to be able to have a lot of very specialist training to do that. And until recently, if you had to build with bioengineering, you needed a PhD to do that, right? Things are getting much easier, where just as, in 80s and 90s, you could start programming very easily and you didn't need a lot of very expensive equipment. That's kind of thing is what is beginning to happen to sort of biology and bioengineering.
Yeah, in fact, to add to that, what Ursheet said, in fact, it may be actually not useful and maybe harmful even to learn biology the way that is taught at the 10th grade, 11th grade. So there are so many questions here you haven't taken past 10th grade biology. The descriptive kind of biology that you would normally learn is probably completely useless. So in fact, even for students coming here who go into bioengineering, in fact, they have to unlearn some of the biology they might have taken, in their high school. So I think it's better to come with a, quantitative background of good mathematics, computer science, physics, etc., and then learn biology the right way when you come to college. And that's what we are hoping to actually do. We want everybody to learn biology, bioengineering in a way that it exposes not only people who are not going to be in biological system engineering, but also others to see the beauty and the power of biology. So that is one of the courses we are designing right off the bat for students who come in, so they can learn about it and then make informed decisions. And I think that may be one of the questions.
Right. So Rama, to build on that, given that the only prerequisites to this major are math and physics in high school, it'll be very interesting to know what is the initial common experience that students go through before they actually have to select their major, and what is special about that. And then maybe we can talk a little further about what is covered in this major as well.
Yeah, that's right. Plaksha has a kind of a unique program that we are designing, which you probably will not have anywhere else in not only in India but also in US. I don't think I've seen anything like this. So this is really a forward-looking curriculum where for the first 3 semesters we want everybody to have deep background in mathematics, computer science that you see in the kind of the gray boxes if you're able to see the screen. And then the green boxes that you see is everybody's going to take those courses in the first 3 semesters, one in each semester. So by the time you finish 3 semesters, you'd have taken all three courses, and you have a glimpse of what the 3 majors are that are coming up. And the first box, the Innovation Lab Grand Challenge Studio, that is kind of vertically going all the way through all the 8 semesters, is actually what you will help apply these problems that are there that Ursheet was mentioning about, of water, energy, health. These are the problems, grand challenges of India, the region, and the globe even, and how to kind of apply it and learn to do it right from the first semester. And then as you progress your understanding and your depth that you gain, then you can go to more advanced aspects of solving those problems. So but the problem solving is actually right from the beginning. So you see context, you see relevance of what you're learning, and that everything is kind of coherent and connected. So that's kind of an experience, educational experience that we have planned for you. So the other overall philosophy of Plaksha has these various pillars. We already talked about the kind of the grand challenge kind of theme that's running through the entire uh, you know 8 semesters. Then you have other cores. We mentioned the kind of the reason why biological systems engineering or even other ones, the cyber physical systems that the majors. The reason why they're exciting is because they're at the intersection of these things. Data science is kind of pervading all through. You'll see it on all the majors. You have the fundamentals of science, engineering, economics, because they're going through all the majors. And then, as you can tell, most of the problems that we have to address, they're not purely technical. They are actually, so you have to have societal context, cultural understanding, ethics. And so we have a humanities, arts, and social sciences as a core that all Plaksha students will get, which is somewhat unusual because usually it's not connected. It's usually it's sitting kind of a little bit diverse from the rest of the things that you learn. What we hope is it's actually connected. So you see how you can apply those knowledge to solve the problems. And also, this is the last piece that you see is kind of leadership. That it's developing a leadership, telling your story, how you creating your own portfolio of how you are developing as a student. These are all skills that you will enjoy in lifelong that you will use. And this is something also for leaders. Is you have to see your own strengths and also even weaknesses and recognize them early on. So these are things that you can kind of practice and put into practice as part of the experience. So these are kind of the two major themes of Plaksha education, not only the first 3 semesters, but also going through the entire 8 semesters.
Rama, there's also a question from Padma that her son likes biology but is not that inclined towards engineering, particularly because of the math component. And although he can do it, but he doesn't like it that much. So is the stream very heavy on math?
I think all the streams will be heavy on math. I think I would sometimes the way that teachers teach and things like that, people when they're young, they might get a feeling that something is not interesting or something. But if it's taught in a way that is contextual, relevant, and applied, and make it interesting, and I think he might be a late blossomer of loving mathematics after he comes to Plaksha. But Urshit, if you want to add something to that.
Yeah, I mean, I think, the math kind of stuff that so first, we have to sort of highlight that this is an engineering degree. So the reason sort of I kind of bring it up is because while the actual bioengineering portion of the degree does not require, much math, the core curriculum for any engineering school will have, about 2 to 3 math courses. These cover the basics that kind of go into things like calculus, and things that just apply other parts, to other parts of engineering. Um, it's, and this, it's not, I mean, a lot of this kind of math these days is also there in commerce degrees, economics degrees, things like that. So, it's not like a math degree, but some basic level of understanding is needed, because the math is sort of the language in which, I mean, would you trust a building built by somebody who doesn't know math, or would you trust a doctor who's not truly being accurate with the math as they are prescribing, anesthesia, or they're giving you anesthesia, right? And these things are made up of different complex chemicals and things like that, and so a lot of chemistry, a lot of physics, a lot of biology. The cutting edge of biology is right at the intersection of physics and chemistry, and that's where math is needed. Um, I will second Rama's point that I think, math is often made daunting by teachers who can be very sort of pedantic. The great thing now is that the set of resources that we have, uh, pretty much most of the math that is going to be needed in this degree can be learned off Khan Academy videos. And so that kind of stuff, I think, is something to be mindful of.
Yeah, one more thing, I grew up, went to school and all in India, as Pali was mentioned, and I have most of my professional life, the last 40 years, I've been here in the US teaching US students. And I see that, the math they come in with in the US, for the most part, the average certainly is much lower standard than the ones that we are used to in India, like calculus 2, calculus 3 is kind of almost the kind of level that we naturally get exposed to in India. So I think if you Indians in general in Indian schools are better prepared in mathematics already. So I don't think there should be any, you know, uh, doubt that they will succeed if, in bioengineering or any other engineering, so long as they apply themselves. So I don't think that should be a worry.
Okay, great. Thanks a lot. And there's another question from Ursheet Parikh that his daughter is interested in biology and math, but not so much in physics. Does this major suit her?
Um, I think I can take that, right. So I think the the future is going to be about, interdisciplinary things across the board, right. You pick up an iPhone today, and an iPhone is an amalgamation of the ultimate things in sort of material science, software, hardware, right, like computer engineering. But also what makes Apple products so much better is, compared to other products, is things like design and the soft factors, the psychology, right. So if you look at like the people who work at companies like Apple on products, forget and like finance and sales and all of that, they cover the gamut across like fields that you would have not have thought that psychology is going to be an important factor. So I think the and then kids are pretty sort of like, people change their minds, and as a new generation you get to learn. So the point on it being that I think it's less about, what people feel they like or they not, and it's much more about what they want to do and achieve with their life, and what all do they need to learn to kind of get there. I do expect that, the core at Plaksha is going to be a very, very strong core with just an exceptional student to teacher ratio. It's rare that you get to start a new degree from scratch at the world class level with a strong emphasis on teaching. And so as we sit and work through the curriculum out on that end, and seeing what is kind of coming together, the goal is to really sort of create a desire for sort of learning, and then, and leveraging that to innovate and create value.
Great,
No,
thanks. Yeah. Go ahead,
I
Rama.
think if I may add, Pallavi, yeah, the other aspect of Plaksha is that, not only what we teach, but also how we teach it. And, also less is more kind of, if you could think of that. In some of the, curriculum of many institutions in India, particularly, it's like packed with courses. There is hardly any time to reflect and think and things like that. So, or learn by experience, experiential learning, and all these types of things. So, in Plaksha, our goal is actually to have a little bit less coursework, because that's you can do less. That in the US, for example, we take like 5 courses a semester, whereas in most of the IITs it's 6 courses a semester, which is actually packing a lot in terms of student work. So that gives time also to learn things more deeper. And so I think that also is a factor that you may want to consider, because it's not that you're taking class after class after class and not have time to not only of course connect the dot between the classes, or have other kinds of fun experiences in kind of making your own things in the maker space that we have there, and various other things that both learning can happen also in the curricular, along with curricular, with extracurricular and co-curricular activities. So I think those are all the spaces that we are keeping it wide open for students, so that they can explore in that fashion and have fun while they're in college.
Great. So I picked up a few very interesting things from what both of you said. One was around how the entire teaching and learning experience is extremely different, uh, and how one can actually use everything that they're learning to build things with it. And Rama, you referred to the maker space. So in that context, when we think about this innovation lab and grand challenge thread that you spoke about earlier, which goes across the entire curriculum from the first semester to the last. Could you expand on that a little more and explain how that is linked to this entire idea of using knowledge to actually build things?
Go ahead, Ram.
Yeah, yeah, okay. I think we should already, pointed to a lot of the things of how, we are bringing together, the knowledge and the learning that we are doing in various other classes and connect it to the problems that you see around you in society, right? So I think that what that does is that it gives you the context. Most of the times, the students are all actually wonderful students, except that if they're not motivated and the context is not there, then they'll not be willing to learn. So that's the only thing. It's just their willingness to learn, not the ability to learn. That's hardly a problem usually. So that's what this Innovation Lab Grand Challenge Studios brings right from the first semester. Usually, what happens, you learn a lot of the basic stuff in the first few semesters, and then at the third or fourth or fifth semester, oh, you'll start learning the more interesting things. That's actually not a model that we are going to be using. Let's start with the interesting things right from the get-go. And so you partner with city, you partner with NGOs, you partner with industry, you partner with startups. So they bring problems of the what to call quote unquote real world into the classroom, and you can then apply the engineering that you're learning, the maker space that you can use, or the math. All of that you're learning is actually bringing it together to address those problems. So I think you see that, and obviously, in the first semester, second semester, your background is not high, right? And then you solve some less, complicated problems. But as you go build your capabilities and expertise, then you go to more advanced, ways of solving the problem. So this kind of vertically, what we also call vertically integrated. That means you start working at each level according to what you're learning, and then as you progress from first year to second year, you can get more contribution from your side. And while you're working with this, you'll have the opportunity to be mentored by people who are senior to you, both senior students as well as graduate students, faculty, postdocs, in the vertical spectrum there. And as you go forward, you will be able to mentor the kids who are coming after you. So this mentoring ability to be mentored and also to mentor others, that itself deepens your learning. So that's kind of the philosophy of this, the Innovation Lab Grand Challenge is going through all the 8 semesters.
Got it. That's really interesting. And actually, if you could build a little more on what are the kind of projects that students could potentially be working on, and we recognize that there's a lot of uh, self-agency involved here, and students would pick the kind of problems they are excited to work on. But just to make it real and give some examples, what could be the sort of things they pick up at undergraduate level?
So, I mean, I think, again, Ushit did bring up some of these problems, but let me just go to this grand challenge. What exactly that kind of grand challenges of the 21st century? This is what actually the National Academy of Engineering, where I was working for several years, is the one who kind of initially kind of came up with this idea of the grand challenges. And then many other institutions have also built on it, including the UN Sustainable Development Goals. So the main idea, there are like four themes are there. One is to make life more sustainable, make life more healthy, make life more secure, and make life more joyful. So these are the four major themes. And in sustainability, making life more sustainable, you have clean water, solving air pollution, having enough food for the population of the world. So these are all in this kind of sustainability theme. They come under that. So those are the problems one could solve there. In the case of health, providing affordable, accessible healthcare to people from distant places like in rural areas and maybe peri-urban areas, things like that would be one. Bioinformatics is another one where data plays a big role. So those are in the kind of the health. In security, you have both cyber security is one kind of aspect of it, and also security from natural disasters like floods and earthquakes and things like that. How can you mitigate the effects of those? So those are some of the problems that could come under the security area, even nuclear security, for example. In the fourth one is kind of the joy. Fourth theme is called the joy of living. Engineering is not just about solving problems, so that's kind of a limiting. It's also creating solutions and creating, imagining things that were not there yesterday to do it tomorrow. So that is what engineering is one of the most creative experiences because of that. And so joyful living is also
So
something.
Rama, you had mentored a lot of students who were Grand Challenge scholars in many parts of the world. So could you give maybe one or two examples of the kind of projects they actually worked on and what impact they managed to achieve even as undergrad students?
Actually, a couple of examples come to my mind. I really talk about it a lot, when I, give a lecture to others about the kind of problems. One was, this girl was very interested in why old people fall. As people get older, they fall, and oftentimes the fall is what actually is a kind of a decline of the health of the older person, because they break hip or they break a bone and then they don't recover as fast. So then she started, finding out that, when you're young, when you trip over something in the road or somewhere, you are able to regain the balance quickly, because when you're young, your muscles kind of respond quickly and you can regain your balance. But whereas when you get older, that ability to regain the balance is not there. So when you trip, you lose the center of gravity, goes beyond, and then you kind of continue and fall. So what she wanted to do was, she designed a plate. She was a biomedical engineer. That was her major. So she designed a plate on which she had young people who are healthier, and then also the older people who are kind of fragile, frail, were both standing on it. And there was little kind of movements applied to the plate on which they were standing. And she had various ways of measuring the expansion and the contraction of muscles. So she had various electrodes on their legs and thighs, and she collected data which muscles are the ones which are responding, coming back to give them the stability or not. And then she used it for giving therapy for the older people. So and she started a company when she was a third year undergraduate at Arizona State University. So these were kind of simple example, but it kind of led to you have your own curiosity. That's what kind of drives your passion. So sometimes that's you're observant of what things are going around you. That's kind of one example. The other one I liked was in Arizona. It gets extremely hot, and people, there is always about, I don't know, half a dozen deaths of kids every year left in the car. When people say, what, I'm just going to dash into the store, pick up a few bananas and come back, and then they get distracted, they go off and do something else. And then by the time they come back, the temperature in the car is, the kid is in the car because they thought they're going to be extremely fast. The temperature has gone to almost 80, 90 degrees centigrade. And so, the baby is, has died. Some few babies have died. So what this guy, he's a computer engineer, but he was also interested to work on sensors. So what he put was, he put a motion detector sensor in the car, and then he put a temperature sensor in the car, And then he had, if the motion is not there for the baby, for example, and the temperature goes above this, suddenly he would send a signal to the 911, that is, calling the police. So, an emergency call. So he kind of had an automatic system working there. And, it was kind of very simple in some sense, but at the same time, it was very, impactful in another sense. So, even things that you notice around you can inspire you to do things like that.
Thanks a lot, Rama, for those examples.
Yeah.
And Ursheet, if
So,
you'd actually like to add, yeah, from the
yeah, I
entrepreneurial
mean,
side.
talk about this, right? Like people want to improve the environment, right? And so you want to sort of not be burning like, fossil oil. You can actually engineer a bacteria to make oil for you. And you can, and there are companies that are doing that. In the US, they eat a lot of meat. And for meat eaters, they want to eat meat, but meat is actually 10% of the emissions for the planet, and people wanted that the taste of meat, and companies, some of the biggest IPOs that happened in the US last year, these companies are worth over 50,000 crores in 5 years of starting, and they did that by basically going ahead and actually engineering yeast to produce sort of the material, the flavors that may be there in meat, but you can just put it with soy, and that kind of changed stuff. So um, I mean, I think the possibilities of this are, like, if you think about any level of manufacturing, if you worry about asthma and you look at all the pollution, you look at like what is, this is the technology that solves sort of the bulk of these problems. There is a question that I saw sort of come up, and I wanted to kind of really bring it up. And it reads as, IITs and other engineering institutes in India have a bad rep for biotech, as students are not able to get, higher packages and placements. And how do I think this changes in the next 5 to 10 years? Uh, this is the core reason why I actually came to work, you know, on this Plaksha initiative. It is because you can't really, you have to sort of have a degree, which is not only education wise at best, but you have to build an ecosystem. So at Plaksha, right, that ecosystem starts with having the top collaborators out from the US. You have the founders, like, the core. Plaksha is started by 60 entrepreneurs. Each of us has gone and done some pretty amazing things out over the years, and there's a very different level of entrepreneurial energy. What we are doing with that is we are also bringing, I refer to an incubator in the US called IndieBio. We are actually creating a similar incubator like that in that same collaboration, which sort of helps how you do that. And this is attracting not just startups coming out of Plaksha, but the best startups on these things to kind of go ahead and work here. And so when we are looking at this, we are looking at this as, how are we going to sort of significantly shorten this cycle? And over time, you're going to start seeing, right? It's already starting to happen. Indian origin people are becoming, billionaires with biotechnology, and our expectation is that this program will end up producing many of those people and many other companies for that ecosystem, while having the opportunities to work in the biotechnology, companies like local Indian companies that are investing big in biotechnology, like the Reliance's, Tatas, but also the global majors, who so far were working primarily with China, but as US and China have a split, are pretty likely to sort of come in. So this will include companies like Illumina, Thermo, Agilent, HP, Novartis, Roche. All of these companies are sort of setting up their offerings as well. It's not just Plaksha that is, we are riding a wave. So we are not doing something that is separate from what is happening all over the world. But what we are definitely doing is to sort of channelize it to be at the same level as where IT and other things would be, from a resource attention that we will end up providing on a program or a degree like this. And then you have to see how serious, like one of those other question on, will Plaksha have campus placements? And the answer is yes. If you look at the tech leaders program, the masters, 1 year masters program, and look at the placement ratings, like scores on that, even in a pandemic here, it's pretty stunning. And not just placement, but like the increase in salaries that people had before and after a program like that. So you do have a lot of people who are doing this not because they are looking to make any money, but this plug as an institute, people are here because they care. And a lot of us are like, I'm giving back, right? I think the Indian taxpayer paid for my education when I was out at IIT, and I could be writing a check, but that alone isn't what sort of helps us elevate, and see where the world is headed. And so, yeah, I'm clearly excited about the prospects, and we think this is. I personally take it as a responsibility. The very fact that I'm here talking about this degree or this major, as a certain sense of responsibility on how we ensure that the best opportunities come to the table here.
Super. Thanks so much. So there was another question on the kind of coursework that one would go through in this major. So Rama, if you want to maybe just give some examples of courses um, that students may be taking as advanced courses.
Yeah. So you saw, the first 3 semesters, how we are building the foundation, right? With the mathematics, the computer science, with the social science, and also these grand challenge themes. So after that, as you can make an informed choice after 3 semesters. That's what we want everybody to be kind of having a glimpse of the majors, and because you may or may not have really understood what it is when you're in high school, understandably so. So after you make an informed choice, and let's say if you choose this biological systems engineering, because uh, as was mentioned before, 21st century clearly is going to be the bio biotech century. There's no doubt about it. And everybody you look at, I was actually listening to a talk by an MIT ex-president recently, and she was saying, out of the 400 faculty that she had talked to, more than 50%, whether they are from mechanical engineering or civil or computer science, etc., they're all working on biologically relevant problems. So, that's a huge percentage. And so that certainly shows how everybody is kind of excited by this. So after you finish the 3 semesters, these are some examples of the courses, and you can see that many of them have labs in it. Cell biology as a lab, genetic engineering as a lab, tissue engineering as a lab. So these are some of the courses that you will take as majors, as part of the major. But in addition, you'll see on the right side, there is a list of electives. And the idea of this is that, the 4 majors that we have, they're actually coherent and connected. Then there is a lot of synergy between them. So what is kind of, a required one for one major would be an elective for another major. So we are trying to kind of build that connection between both students and other programs. So the machine learning, manipulation of robots, and signals and systems, which will be in the kind of the cyber physical systems courses, etc. So they will be available to you as elective because they're already taught as part of the other major. So I think you'll get a wonderful chance of kind of not only building depth in the biological systems engineering program, but also getting the breadth across the other programs as well. So that's kind of part of the reason why we have chosen to launch these 4 majors. Not also withstanding the fact that these are kind of aligned with the 4th industrial revolution and kind of forward-looking majors. So that's kind of the second reason that we have launched, is because we can kind of build on this synergy that automatically naturally exists here. So these are some of the courses, the list of courses, but just the titles. But we do have a little bit of more detail on the fundamentals of biodesign and human planetary health. And if you want that, we could share that with you. But if you have more questions on that.
Okay, thanks a lot, Rama. I think there's also this question around recommending some books to get started with genomics and genetic engineering. So it seems like some students want to get started on it already.
Yeah,
Ursheet,
I
Rama, do
would
you have any
suggest,
recourse?
yeah. So one of our Plaksha advisors and my partner at Mayfield, who started in Bio, has written a book called Decoding the World. Highly recommend that. And if I mean, I'm sure it's available in India. But if it isn't, kind of let us know, and or we can try to find. I think it should be hitting paperback soon as well. But yeah, there's a lot of great stuff that is out there when you start looking at sort of engineering biology, synthetic biology, and sort of the set of things that are changing. So decoding the world, recommend in a heartbeat.
Yeah. The other book I think I would recommend is this is the one that I referred to before. It's written by former president of MIT, Susan Hockfield, and that book is called Age of Living Machines. So the Age of Living Machines is a very, very easy to read book. And you can also Google it, and she's given some talks and 1 hour talks about this, capturing it. So I recommend, very easy to understand. She's a wonderful presenter and a teacher, as you can tell from the way she presents things about it. And one of the things actually that really struck me in that book was there was a diagram about how IT has been progressing the last 50, 60 years, because of the, I don't know, maybe you have heard of this thing called Moore's law, right? So how things are actually, going, half the size in 18 months, and things like that. But if you look at biotech, like Ursheet was mentioning about the cost of the, you know, making the genome, analyzing the genome, it has come down from the first one. The very first was $100 million, but the now it's $100. So if you plot the same thing with the IT and the biotech is like orders of magnitudes faster than information technology. So this again points to the fact that the future really belongs to this revolution, and of course using the all we have gained from in IT as well. It's not just that's left behind, but that book is a wonderful book, Age of Living Machines.
Okay, awesome. If you could actually write those recommendations in the chat as well, that would be terrific. There was this one other question that Ursheet, I think you were also typing the answer to, on whether the bioengineering degree at Plaksha at an undergrad level is sufficient to get a great job in a biopharma company, or does one need a master's program? Would be great if you could also answer that for the rest of the audience.
Yeah, it depends on the type of the job. And often a lot of the jobs if they require a lot of skill, it needed graduate degrees, or postgraduate degrees, what they call graduate degrees in the US. But that proportion is beginning to go down. 10 years ago, if you had to actually create a new drug with a DNA or an RNA, you needed a PhD. Today, a 12th standard student can actually order all the things you need to do that off Amazon and actually engineer and build something and prototype out on that end. So it's getting a lot easier to do that. Not too different from how, like 30 years ago, 40 years ago, if you wanted to do something in computer engineering or electrical engineering, you needed much more advanced degrees. To today, anybody can program and write code. And so it'll depend on the degree. A lot of the on-the-job experience, a lot of those things will matter as well. But it's in many ways it's a specialist degree. So what you have is not as commodity and not as easy to find for everyone. And then if there are, like, so say somebody's talking about neuroengineering, is it a subfield of bioengineering or biomedical engineering? So if you are trying to do deep neuroscience stuff like new brain treatments and things like that, a lot of it will show up in bioengineering. If you're trying to do like a device or a stent or something, it shows up in biomedical engineering, which can also be part of bioengineering. But like a focus degree in neuroengineering is really a graduate degree, right? Or a postgraduate degree, right? You have to do a master's or a PhD today for that kind of a degree. So that hopefully kind of gives you a feel. The idea is that it's the degree is not the end all be all, right? These degrees are about getting you enough to be able to build and be useful at work. But the future of work is that you have to be learning constantly and continuously, because things move so fast that it will get obsolete as well. So clearly these things are all being designed with having the most relevant skills to be in the workforce. And this is also where, when you look at like the depth and the breadth of the curriculum, there is a certain level of rigor and a bias to build. But yeah, I mean, I think The backup in all of these degrees is always a programming job. Fundamentally the difference between what I would say a biotech versus bioengineering approach is that bioengineering doesn't happen without really knowing how to code, use AI, use cloud computing, and building with it, right? So that part is there. The difference though is that in America, 1/3 of the GDP now is healthcare or biology, and if you're looking for jobs in those companies, you end up finding that having the bioengineering part ends up actually giving you a lot more of an edge, even on computing jobs, than just a raw software degree. Because biology, like, see, software is powering every industry, right? Everything is getting reinvented, technology. And so then the skills of that industry also become as important as just basic software skills.
Terrific. Okay, great. So we've been getting tons of questions on admissions as well through the last hour. So I just want to invite our colleague Sanath at this stage to maybe spend the next 5 minutes just walking through the questions that have come on that.
Oh, thank you. Hello, everyone. I'm Sanath from Plaksha's admissions and outreach team. So just to give you a sense, of course, you got to know a lot more about the biological systems engineering major today. I got to know a lot more about it. Plaksha is starting in 2021 with its B.Tech programs. We offer 4 majors. As should have been clear by now, you don't have to declare your major before coming to Plaksha. Students are required to have studied math in 11th and 12th for all 4 of our majors. And for the first 3, you also need to have done physics. On the admissions process itself, it's fully online. It's completely free of cost, quite similar to other liberal universities in India as well as abroad. In the first stage, you have to submit an online application form in which we require you to submit your grades from 9th to 12th. In case you're yet to appear for 12th boards, which would be the case for most of you, you can just write your predicted grades. At least for this year, entrance exam scores are not mandatory, but you do have the option of submitting your SAT, JEE mains, ACT scores, KBPY, or if there are any other entrance exam scores which you feel would be beneficial. The advantage of submitting an entrance exam score is that you could get a firm offer sooner. So suppose if you're applying with your 12th predicted scores only, then at best you can expect to get a conditional offer from us, and the final offer will depend on the marks you get in your boards. Alongside academics, we do want students to talk about their personal story, any extracurricular activities they've done, co-curricular activities, etc. Now, I know there have been a couple of questions on, what is the minimum grade requirement? How seriously do we take extracurriculars, etc.? The short answer is that we're not too rigid with any of these categories. We don't have any cutoffs or minimum scores, so to say. As far as extracurriculars are concerned, it's not like you would be penalized for not having any extracurricular, but we do want to see that you have tried to do something that goes beyond the classroom. Now, after you're done with filling this form, which takes about 4 to 5 hours, students are required to come for a virtual interview. And students typically receive notifications about 3 to 4 weeks. As part of this virtual interaction, this is quite unique and exciting itself. You have to go through a design challenge wherein you are given a case study and you have to respond to it in a fixed amount of time. And then you go through an interview, about a 30-minute interview with our panelists. A couple of questions on the fees and financial aid. Our fees is approximately 8.3 lakh rupees a year. This is the same for all B.Tech programs. And this includes the living costs. Now, alongside that, a very important thing about Plaksha, as Ursheet and Dr. Rama have been saying, is we are a collective philanthropy, right? And what that also brings is we are committed to ensuring that no student is restricted from attending Plaksha simply for financial reasons. If you feel that you'll fit into Plaksha, you can apply. And after that, we'll give you the option of applying for financial assistance, and you get anywhere between 0 to 100% aid. We expect close to 15 to 20% of our students in the first batch itself to be on 100% financial aid, and then another about 50% to be on some form of financial aid. So in summary, I'll say that If this is something that you're liking, but you think that this fees might be difficult for you, don't worry about it. You can apply, and I'm sure we'll make something work. Alongside that, we also have a small amount of merit-based scholarships. There's no separate application for that. All students are automatically considered. So in case any of you are planning to apply, our applications opened in November. We are currently in the second round, and the deadline for that is 21st of March. But you technically have time till June to submit your application. The advantage of applying sooner is that you get your results sooner. So I think that's it on the admissions.
And there was a question on the accreditation. Can you talk about that, Sana?
Yeah, sure. I think I also responded to an earlier one, but basically we currently have the letter of intent from the Punjab government. So just to give you an idea, because Plaksha is a university and not a college, we don't need AICTE. What we do need is the State Private University Act, and we are on track for getting that. That's something will definitely have in place before we start. So that would give us the authority to award degrees under the name of Plaksha University, and they will be accepted like any other B.Tech degree, both in India and abroad. The second is UGC. Now, UGC certificate usually comes about 18 to 24 months after a university starts. All our courses are fully in guidelines that have been released by the MHRD and UGC, so that by the time a Plaksha student graduates, their degree would be under Plaksha University and also recognized by UGC.
There's a question on whether somebody can start at Plaksha and transfer to universities abroad. I think you can pretty much do that out of any university. I do think that visibility and collaboration opportunities are potentially more at Plaksha simply because there are named heads of departments at other universities who are aware and are probably engaged and involved. Though if you do want to study abroad, yeah, I mean, the approach on something like this is that you're getting that quality of education in India without having to basically spend, the US education fee, which is, 50 lakhs a year.
Great. I think we're at 10:30 now. So thank you so much, Ursheet and Rama, for a really enlightening session. Similar to Sanath, I got a lot to learn over the last hour as well. Thank you very much to the audience to join into the session on a Saturday morning and for asking us really good questions. That made the session fun for everybody. If you have any further questions, please don't hesitate to write in on the admissions ID. You can always send us follow-up questions and we will certainly get back to you. We look forward to seeing your application soon. Rama, Ursheet, if you have any closing comments, over to you.
It was fun. Enjoyed talking to you, and looking at all the questions. I mean, I've been trying to really gauge the kind of interest and the insightful questions they're asking. So very excited and hope to see some of you at Plaksha this year, I guess.
Yeah, this year. I'll just say two things in closing. First, I think Plaksha is a passion project for people who really care and want to sort of elevate the level of cross-functional, multidisciplinary education to sort of really power the next generation of leaders and entrepreneurs for the country. I think, and that applies to every degree that is there. And then, when it comes to sort of the biological systems engineering degree, right at the core and the charter of when it was formed, a very near and dear question was that it's not just a degree, it's about how we make this the key anchor around an ecosystem. And stay tuned to see what will be some of the big world-class sort of game-changing announcements that will show up that will be a testament to how it is not just a degree, but the creation of an ecosystem, an innovation ecosystem, for the country.
Terrific. Thank you so much. Good night, Rama and Ursheet. Good afternoon to everybody else. Have a great rest of the day.
Yeah.
Bye-bye.